Okay, so hi everybody. So today, we're going to go ahead and go over what it would be inverse and piecewise functions. Okay, so let's just get right into this. Okay, so definition 1.3.1, inverse function. In mathematics, an inverse function is a function that reverses, that's the important word to remember there, another function. It undoes another function. That is, if f of x and gx are inverse functions, then f of g of x is equal to x. I know this doesn't make much sense to you, but all this means is if you were to plug in x, you're going to get out that same value. Okay? Now, we often write the inverse of f of x as f to the negative first of x. Okay? That's important to understand. That is not the negative exponent property. Like x to the negative third, we can write as 1 over x cubed. That is not what we're talking about here. This is simply a notation of a function f inverse that undoes f of x. Now, I know that doesn't make sense, but we'll get into it. I think it will make sense as we get moving. Okay, so note, if f and g are inverse functions, then the domain of f is the range of g. So it's really nice about domain and ranges of inverse functions is they simply flip-flop. Okay, so the domain of one function is the range of its inverse. And the range of one function is the domain of its inverse. Okay, so that's one part. The other part is the graphs of f and g are reflections across the line y is equal to x. Excuse me. So what that means is, say, for example, I had a graph, and the graph looked like this. It was a parabola. Okay, and I call this f of x. What that means, the second part, the reflection across the y-axis, is if you add this equation, which is y is equal to x, then if I was to just reflect this graph across this line, it would give me its inverse. Okay, so the reflection there, that point's going to stay on the line because it's on the line. That point's going to stay on the line. That point's going to go there. That point's going to go over here. So the graph will end up looking like this. Okay, so this would be the inverse function of f. Okay, so method for finding inverses. You will need to know how to do this. Okay, it's a pretty simple process. All it involves is a little bit of algebraic manipulation. So solving for a variable, for x or y, whatever it is. Okay, so the first thing you're going to do is you're going to switch the x and the y, and then you're just going to solve for the y variable. Okay, now there's two steps that I kind of avoided. When it's in this notation here, you first want to change f of x into a y. So if you want to insert, you're going to change f of x into y first. And at the end, once you get your answer, you're going to change y to f inverse of x. Okay, so what does all this mean? Okay, so here we go. We're going to take this, we're going to start by, instead of writing f of x, I'm going to write it within a y. So I have y is equal to 3x minus 2. Okay, now switch the x and the y. So x is equal to 3y minus 2. And then we just solve for y. So I'm going to add 2 to both sides. So I have x plus 2 is equal to 3y. And then divide both sides by 3. So I have x plus 2 all over 3 is equal to y. And now, like I said, we're going to change the y into f inverse. So therefore, the inverse function of f is equal to x plus 2 all over 3. Okay, now I quickly want to show you what the graphs of these look like. So that way you can see that it's a reflection across the line y is equal to x. Okay, so this right here is in slope-intercept form. That is y is equal to mx plus b. It has a y-intercept of negative 2. So 1, 2. and it has a slope of 3. So from this point, you can go up 1, 2, 3, and over 1. So that line looks like that. Okay, now this one right here, I can write as 1/3 x plus 2/3. This is called the distributive property of division. I take x divided by 3 to get this, and then 2 divided by 3 to get this. So this is a y-intercept of 2/3, which is going to be right there, and has a slope of 1/3. So from there, I'm going to go up 1 and over 3. So 1, 2, 3. So it's going to be like right there. And the slope of that line is going to, or that line will look like this. Okay, now if you look at where the line of y is equal to x is, y is equal to x is the line that looks just like this. So you can see that this line right here is a reflection about over this line, which gives you that image. Okay, if you were to hold a mirror up right there, this line would turn into that line. Okay, let's do another practice problem. Okay, so given that g of x is equal to this, find g inverse. There should be an x here, but you don't have to write it that way. Okay, so first step, we write it with the y. Okay, step 2 is we switch the x and the y. So you have x is equal to y minus 2 squared minus 3. And then we solve. So add 3 to both sides. So x plus 3 is equal to y minus 2 squared. Now I need to get rid of the squared. So I don't know if you remember how to do this, but what you do is you take the square root of both sides. Now, you have to be careful because when you take the square root, you must have a plus or minus in front of it. Okay, so when I do this, I get plus or minus the square root of x plus 3 is equal to y minus 2. I add the 2 to their side, so 2 plus or minus the square root of x plus 3 is equal to y. Now that I solve for y, now I just need to rewrite y as f inverse. I'm going to go up here. So I get f inverse, actually it's g inverse, right? Because we're doing g. G inverse of x is equal to 2 plus or minus the square root of x plus 3. Okay. Now, I'm going to quickly go over this, and I know it's probably going to be a lot here, but I want to show you graphically what these look like, okay? So this right here, hopefully you can recognize that the parent function is a parabola, right? It's y is equal to x squared. It shifted 3 units down, and since this is inside the parentheses, it shifted 2 units to the right. So 1, 2, 1, 2, 3, and the graph looks like this-ish. It's a little bit off over here, okay? Okay, now what does this graph look like? Now you actually have 2 different graphs. You have a plus and you have a minus. So square root function, hopefully you recognize that this is a square root function, and this 2 has moved it up 2 units. So I'm going to go 1, 2, and then this represents it's moved 3 units to the left. So 1, 2, 3. So the graph will look like this. So it's going to go, so normally it goes like this, but it shifts up 2 and 3 to the left. So the graph will look like that. And now the minus portion of it is actually going to bring it down below here. So it's going to look like this. Okay, and you can see that if I drew in the line y is equal to x, that 1 is the reflection of the other. Okay, now you don't really need to graph the inverse, but it's nice to know what their relationship is. Okay, next page. Okay, we'll do one more example of these, and then we're going to get into what a piecewise function is. Okay, so if I find h inverse of x, so y is equal to 6 minus 3x. switch the x and the y, and then solve for y. So minus 6, x minus 6 is equal to negative 3y. And then divide both sides by negative 3. Let's go up here again. So I have negative 1/3 times x minus 6 is equal to y. So I have, and I switch the y back to f inverse, actually h inverse. Gotta be careful there. Is equal to negative 1/3 times x minus 6. Now I want to show you a little trick that mathematicians do. Because having this negative out here is kind of dangerous. It's easy moving forward to drop off a negative, and that negative can mean everything in the world. Okay, it can actually account for very, very large mistakes. NASA has lost rockets upon launch because they have done stupid things like that. They've left off negatives. The most famous example I can think of is I think they forgot to put it into metric. So they had metric versus standard in the same calculations, and they didn't catch it, and it ended up blowing up the rocket. Okay, so what we can do is I can distribute the negative into the parentheses, so I don't drop that off. So if you notice, the x right now is positive, and the 6 is negative. So if I distribute that negative in there, it's going to be 1/3, and I'm just going to write it as 6 minus x. Okay, the 6 which was negative now turns positive, and the x which was positive now turns negative. Okay, you don't have to do that. You can leave your answer like this. I just wanted to show you the common trick that mathematicians do. Okay, next definition, piecewise functions. Okay. If you have a brother or sister and you're always complaining, you treat them differently than you treat me. That's essentially what a piecewise function is. Okay, depending on what you're talking about, what number you're talking about, you're going to plug it into a different function. Okay, so here's where we have this. We have this function that has two different possibilities of functions it could be. It could either be 3x minus 2, or it could be x squared plus 2. Now, which one of these you use is dependent upon these criteria. So these are the functions, and then these are the criteria which makes it work. If it is less than or equal to 0, I'm going to use this top equation. If it is greater than 0, I'm going to use this bottom equation. Okay, so the first question, find f of negative 1. Negative 1, is that less than or equal to 0 or greater than 0? Hopefully you've realized it's greater than, less than or equal to 0, sorry. So in other words, I'm going to use that equation. So f of negative 1 is equal to 3 times negative 1 minus 2, which is negative 3 minus 2, which gives me negative 5, and that's my answer. That's all I have to do. Okay? Find which one of those functions this is actually talking about and use that function. Okay, so given that g of x is equal to this stuff, you have the absolute value of the square root, x is less than or equal to 2, and then x is greater than 2, you want to find g of 2. Well, we're going to use this top equation because it's less than or equal to 2. So I have g of 2 is equal to the absolute value of 3 times 2 minus 8, which is equal to 6 minus 8, which is equal to the absolute value of negative 2. Remember, absolute value always has to be positive, so it is 2. Okay. Now, just real quick, why does it have to be positive? Absolute value, by definition, is the distance away from 0 on a number line. So how far is negative 2 away from 0 on the number line? It's 2 units. Okay, and then the last question right here. Okay, so given you have this function h of x, you have these two different functions I could use. If x is less than 4, I'm using the top. If x is greater than or equal to 4, I'm using the bottom. I'm finding h of 3, so therefore, once again, I'm using the top equation again. So h of 3 is equal to 9 over 3 plus 2, which gives you 3 plus 2, which gives you 5, and 5 is the answer. Okay, so those were inverse functions and piecewise functions, okay, both of those. Okay, if you have any questions, please feel free to reach out to me, and I'll do my best to help you out. Thanks, everybody.